Okay, this is our typical truss problem. For this particular truss itself, we want to know what the forces are that are supported by member FG, which is this member here. If we look at this, we know that we'll have to find our reaction forces at A and at N. And by inspection, we can easily see what those reaction forces are. At A, because it is symmetrical, everything is symmetrical, we have an AY. We see that that will be 1 kilonewton. And then at N, we have another reaction force of 1 kilonewton and nothing in the X direction here, right? This will be 0 kilonewtons. Okay. So now we want to look at this truss and decide how we want to solve it. Because we only want to find just something for one member, just FG itself, it's best if we can use method of sections. It's usually the quickest way to solve these problems, but sometimes it can be a little tricky. If we look at it, typically we want to cut through the member that we want, right? So if I cut through this way, I'll have 1 unknown, 2 unknowns, 3, 4 unknowns. We can only solve for 3 unknowns. If I cut this way, 1, 2, 3, 4. So we seem to only have 4 unknowns for most of the ways that we can cut. But if I look at this, I could make a cut through here, AA. And if I solve this, then if I look at the free body diagram for this, I would have a force here, and a force here, and another force down here. With this, though, I could analyze this and solve for this force, three of these forces, right? I could solve for all of them. And let's take a look and do that and see what we can gain from this. Okay, so I've drawn the free body diagram for this problem, and now if we look at this, we can easily analyze for these forces. The first place that I want to look, though, is where I want to solve for it, right? And typically, again, I like to take moments where I can eliminate most of the unknowns. So if I look at this point F here, if I sum moments at that location, I don't have to worry about Fi or Fh, and I can solve for GH. So let's start there. That's a good place to start. Okay? Okay, now let's take our moments, and we're going to sum moments again at F. So we can get rid of as many variables or unknowns that we have. All right, so we have our 1 kilonewton force at A, which is going to cause a negative moment around F, and that's at 3 meters. We have the next one, which causes a counterclockwise rotation at 1 meter. And then we have our moment due to FGF. We know the component that's vertical or in the y direction itself, in this direction, will not cause a moment about that point, but the component in the x direction will cause a moment. So let's look at that. That component is FGF times 1 over the square root of 2. And that will cause a negative moment, and its moment arm is this 1. This we can then solve real easily for FGF, and that will come out to a negative 2.828 kilonewtons. Okay, so now if we take a quick analysis of what we have and what we know this force here. We don't know these two members here. We don't want to know them anyways. The one we really want to know is this one here. If I look at this a little bit, if I look at this point G, we have essentially, if I look at that node or that joint, I have 2 other unknowns, this GF, and then this one here, which is really EG. So I could use method of joints at G and then solve for this one that I'm looking for. So let's do that. Okay, so now we have the free body diagram for joint G. if I look at that, I can solve for FGF, and that's the one I'm really looking for. I really want this force right here. If I sum forces in the x direction, I could solve for EG. I don't really care about that one, but if I sum forces in the y direction, that will give me the value for FGF. So let's sum forces in the y direction. That should equal 0. And in the y direction, we have a minus FG minus our minus 2.828 times the component 4, right? The component is 1 over the square root of 2. If we solve for that, we will get FG is equal to 2 kilonewtons. Okay. So to recap, let's kind of take a look at what the steps we did. We had this problem. We couldn't cut it any direction where we wanted to know what that FG member was. So we had to pick some other method, right? We could have done method of joints, and we'll do one of those, but you'll see there's a lot of joints to go through on this, so that would be a little bit of a pain. So we wanted to use method of sections, and we found that if we cut through this AA section, that would have been a good way to cut. We only have 3 unknowns. We solved in this free body diagram the unknown of GH, which is really handy. Then we could go into looking at the joint method at G and solving for that particular joint. On the exam itself, you'll see that this truss problem, there will be a truss problem on there. This one is a very large truss one. The other one will be a little bit smaller, so you will have the option of doing method of joints or method of sections. The sections one, again, will be a little quicker in some ways, but you may be more comfortable with method of joints. I hope this helped.